If your home was wired in the last 50 years, there is a better than even chance the electrical system inside your walls is held together by connections that fail in slow motion, certified by a private lab, paid by the manufacturers it tests, and quietly aging in ways no inspector is going to catch. A 1925 brick bungalow with its original knob and tube wiring is statistically safer than a 2018 new build with all the modern panels and arc fault breakers. That sounds wrong. On the available evidence, it is also true. And when you hear what a single $5 component is doing in roughly 28 million American homes right now, you will understand why the engineers who tested it have been trying to sound the alarm for 40 years, and why almost no one has heard them. Picture a modern electrical panel, the gray metal box in your basement, neat rows of black breakers, everyone labeled. It looks orderly. What you are staring at is the cheapest legal version of what an electrical system is supposed to be. The insider phrase is code compliant. That phrase does not mean safe. It means the inspector signed off, the deed transferred, and the builder's liability ended. In 1925, an electrician wired your house to outlive him. In 2025, he wires it to outlive the warranty. Failure point 1. The outlets in your home are lying about how they are connected. Behind every wall outlet, the wires are held by one of two methods, either wrapped around a screw and tightened, the way every outlet was wired before 1980, or jammed into a small hole in the back that grips them with a tiny internal spring. That spring is called a backstab, and it is the fastest, cheapest, most failure-prone connection the National Electrical Code allows. A backstab saves 30 seconds per outlet. A 2,500 square foot home has roughly 100 outlets, an hour of saved labor per house. Spring tension fades. After 10 or 15 years inside a wall, the spring loses its grip. The connection loosens. The contact point starts arcing, and the outlet either dies silently or starts a fire. The Consumer Product Safety Commission links residential receptacles to roughly 5,300 home fires every year in the United States. The outlet itself costs $4. Finding which one of your 100 outlets is failing runs $300 to $600 in diagnostic time, assuming you find it before the wall does. Failure point 2. The cable that runs every circuit in your home is called NMB. 2 or 3 copper conductors and a bare ground are bundled inside a thin plastic sheath and drilled through the framing studs. The plastic is thermoplastic. It hardens and cracks with heat exposure over decades. The National Electrical Code itself states that when more than 3 current-carrying cables pass through the same drilled hole, almost every drilled hole near your panel, the cable's ampacity has to be derated. In residential construction, it almost never is. The code already knows that bundled cable cannot dissipate enough heat. The builder knows no inspector is going to open the wall to verify it. Compare that to a 1925 home wired with knob and tube. Each conductor runs individually through ceramic insulators with 6 inches of airspace between hot and neutral. Every splice is hand soldered and wrapped in friction tape, slower and more expensive. And it is the reason 1920s wiring, undisturbed by a renovation, routinely passes functional inspection 100 years later. A whole house rewire today runs $8,000 to $25,000. Failure point 3. The panel itself was built to a price point. Inside every breaker box are 2 metal strips called bus bars, the spine that distributes power to every breaker. And in a square DQO panel, considered the residential gold standard for 40 years, those bus bars are solid copper. In nearly every panel installed by a volume builder over the last 20 years, the bus bars are aluminum. Aluminum oxidizes. Each breaker locks onto the bus through a small pressure connection, and over time, that connection develops oxide buildup, increases resistance, generates heat, and eventually melts the bus bar at that contact point. You can replace the breaker. You cannot replace the bus bar without replacing the entire panel. A copper bus panel costs the builder about $150 more than aluminum. A full panel replacement when the bus fails runs $1,800 to $4,000. Failure point 4. There is a brand of breaker installed in approximately 28 million homes built between 1950 and 1990. It was sold under the name Federal Pacific Electric Stab-Lok. In Canada, the same product was rebranded Federal Pioneer. The breakers carried a UL listing, which meant Underwriters Laboratories certified them as compliant with safety standards. Independent engineering studies, beginning with Ehrenstein and Tobias in the early 2000s, used UL's own test methodology and found that mass production Stab-Lok breakers fail to trip on overcurrent at rates between 25% and 65%, averaging around 51%. That is a coin flip. A breaker that does not trip lets a short circuit run until something on the other end of the wire melts. The Consumer Product Safety Commission opened an investigation in 1981 and closed it after Federal Pacific filed for bankruptcy, citing budget constraints. UL never withdrew the listing. Federal Pacific panels were never recalled. They are still sitting in approximately 28 million American homes today. Replacing one costs between $1,800 and $4,000. The single $5 component, when it fails the way Ehrenstein documented, can ignite a wall fire that costs $60,000 or more. So who is responsible? The volume builders are obvious. They specify the cheapest panels, the smallest bus bars, the fastest terminations, because their incentive is cycle time and unit margin, not the next 40 years of your life. They are logistics companies that ship subdivisions on quarterly earnings deadlines. But the real story is the testing body that was supposed to catch this. Underwriters Laboratories, UL, listed the Federal Pacific Stab-Lok breaker. UL is paid by the manufacturers it certifies. UL never withdrew the listing despite 4 decades of documented failure data. A testing organization paid by the companies it tests is not consumer protection. It is liability management with a logo on it. So what is actually worth your money? Number 3. Hire an independent electrician for a panel inspection. Not your home inspector, who only looks at the panel cover. An actual licensed electrician, with the cover off, looking at the bus bar, the breakers, and the splices. It typically runs $150 to $300. Ask them to flag Federal Pacific, Stab-Lok, Federal Pioneer, Zinsco, or aluminum branch wiring. Number 2. Houses built roughly from 1985 to 2005 were wired with copper Romex and a square DQO panel. The era of aluminum wiring was over. The volume builder collapse had not yet arrived. Number 1. A pre-1965 home with its original copper wiring and an original Cutler hammer or square D panel. Before aluminum wiring. Before Stab-Lok. Before the volume builder collapse. Every connection in that house was made by an electrician whose reputation was the only marketing his company had. Whatever home you buy, do one thing. Pull the panel cover, photograph the breakers and bus bar, and search the brand names against active class action settlements before you sign. It costs 10 minutes. Here is the line to walk away with. A modern home is wired to outlive the warranty. A 1925 home was wired to outlive the man who installed it. The builder's incentive ended the day you signed. Yours starts the day you move in. Those incentives have never aligned. If this saved you from an expensive mistake, subscribe. Next week, we are going underground. There's a specific concrete additive used in millions of homes built since 2005 that is silently destroying foundations from the inside. We are going to name what to look for. I will see you then.